Let's read our objectives first for our lesson 4.6 on solving two types of equations. The first one is an exponential equation. The second part is the logarithmic equation, okay? Let's read let's see in here the first two objectives first, okay? Eva, go ahead please.
Use like bases to solve exponential equations and use logarithms to solve exponential equations.
Thank you, all right. So in here it says use like bases to solve exponential equations. So when you say like bases, you have to consider the rules on exponents, right? Rules on exponents. Like what? Product rule, call it PDT, right? Quotient rule, right? When you are subtracting exponents, right? And power rule, right? When you are multiplying exponents, right? Power raised to another power, okay? Now in here, when you say use logarithms to solve exponential equations, we are now considering this one the exponential to logarithmic conversion, right? Exponential to log conversion, right? So if you can review that one, then that will definitely help, right? Once again, like bases, we have to use rules and exponents for such. And the second one, use logarithms to solve exponential equations. You have to, have that knowledge of converting from exponential to logarithm. Are we good? All right. Let's start with this one. Let me just put an X for this one and do this worksheet. Okay, so here it is. Let's read the first instruction in there. All right. Let's read that one. Marguerite, go ahead, please. Use.
So the following exercises use like bases to solve the exponential equation.
Like bases. So what's the base in here for number 5, for example? What's the base? 4, right? So I would say in here, step 1, express everything, right? In terms of what?
4.
Base 4. Very good, right? That is correct, right? So how would you express 64? As 4 raised to a power. And also, how do you express 16? As 4 raised to a power, right? So, what do you think, guys? Let's say 64 is 4 to what power?
The third.
Cube. Very good, right? 4 cube, right? Now, also in here, I'm going to put in the given, 3x. And then in here, the 16, I'm going to express it as what? 4 raised to what power?
Square.
Square. Good. So again, the step number 1, express everything with the same base. In here, the same base is what? 4. Okay. And then after that, what do we do? Step number 2, use exponent rules, right? What exponent rule or rules should we use for such? For example, here on the left side, if you have 4 cubed times 4 to the 3x, what rule should we use for such? Product rule, quotient rule, or power rule?
Power rule?
Power rule, if you have a power raised to another power, right? But this one, you have this 4 cubed multiplied to 4 to the 3x power, right? And what rule is that? Okay. Well, this will give you an idea, right? Product rule, right? For exponent, right? So product rule for exponent tells us what? What do you do with the 4? The same base? Just copy it, right? 4. Now what you're going to do with the 3 and the 3x? You're going to add them together, right? Very good. Get the sum. Okay, so it'll be what? 3x plus 3. Or just 3 plus 3x, right? By commutative property is equal to what? 4 squared. Okay? Get it, guys? Okay. And the last one in here is this one, okay? Last one in here is such. Step number 3. We're going to use, this is what we call the 1-to-1 rule. Or property for exponents, right? Telling us that if the base are the same, then what can you say about the exponents?
You can separate
they're the same. Very good, right? That means what? If the bases are the same 4, then that means the exponents 3x plus 3 on the left and the 2 on the right should be the same. Are we good, guys? Okay, and again, that's called what? One-to-one rule for exponents. Okay, and the last one, step number 4. So what do you do with this? Step number 4. Well, solve for x, right? Solve for x. Okay, so what do we do in here to solve for x, guys? Giselle, what do you do first?
I subtract.
Subtract 3 both sides. Very good. Okay, cancel. 3x is equal to what? What's going to happen to the right side of the equation, all right? Adam, what's that? 2 minus 3. Very good. Negative 1. And the last step. What do we do for the last step in here?
Divide by 3.
Divide by 3. Very good, right? That's it, right? X is equal to negative 1. Okay. So once again, this is our how-to for like bases solution, right? Express as same bases. In here, all base form. Okay. Next, use exponent rules. In this case, we use product rule. Sometimes you can use quotient rule. Sometimes you can use power rule. In some cases, you would use a combination of those, right? Next, use the one-to-one rule property for exponents, telling us that if the bases are the same, that only means that the exponents are also the same. Okay, so just bring down the exponents without the bases and solve for x. Are we good? Get it, guys? Last step. The last step in here is definitely step number 5. Substitute back, right? Back substitute to verify, okay? Okay. So how do you back substitute that one, right? So you put it in here. Let me just continue in here, guys, right? Is it true that from the given, so this is the given, right? That 64 times 4 to the power 3 times, what's this again? Negative 1/3, right? That's your x. Is that equal to 16? Are we good, guys? Right? Again, your x from the given is negative 1/3, right? Oh, first, what's 3 times negative 1/3? Negative 1, right? So that's 64 times 4 to the negative 1 power. Is that equal to 16? Well, negative exponent rule, right? What's 4 to the negative 1 power? 1/4, right? And this is 64. Now, is that true? That's 64 divided by 4. Is that equal to 16, guys? Yes, it is, right? So, yes, we have confirmed that the answer is right, okay? Otherwise, if not, then it's called, if not a solution, then it is called what? It is called what we call an extraneous solution, right? Extraneous solution, right? Yeah. If it turned out that if you back substitute the equation, it doesn't turn out to be right, then it's called what? Extraneous solution, right? That it's a solution on the algebraic process, but if you put it back into the given equation, and I do mean it does happen in some situations, that is called extraneous solution. Are we good, guys? All right, so thank you.